Hello students, I, Trupti Patel from Arihant College of Arts, Commerce and Science. Today we are going to study hydrolysis of salts. Students, first let us study what is the meaning of hydrolysis, and then we will study the types of salt. There are 4 types of salts, like as you can see. So first we'll study hydrolysis of, what is the meaning of hydrolysis? So the concept of hydrolysis, when a salt is dissociated in water, it dissociates completely into its constituent ions. The solvent water dissociate slightly, as you can see in the reaction. H2O liquid form plus H2O liquid form, which gives you H3O plus ions plus OH minus ions. So the pure water is neutral and H3O plus ions is equal to OH minus ions. If the ions of the salt do not interact with water, the hydronium and hydroxyl ions concentrations remain equal and the solution is neutral. When one or more of the salt ions reacts with water, like see, first one was when the ions of the salt do not interact with water, right? Now the second is when one or more salt ions react with water, the equality of the concentrations of H3O plus ions and OH minus ions is disturbed, obviously. So with this hydrolysis concept, the solution does not remain neutral and becomes acidic or basic depending on the type of salt. Such a reaction between the ions of salt and the ions of water is called hydrolysis of salt. So hydrolysis of salt is defined as the reaction in which cations or anions or both the ions of a salt react with ions of water to produce acidity or alkalinity, or sometimes even neutrality. So I hope students the meaning of hydrolysis is clear. So based on this concept of hydrolysis, we have 4 types of salts. First one, salts derived from strong acid and strong base. Second, before going to second, examples, students. For example, you can see the examples also. So salts derived from strong acid and strong base, NaCl, Na2SO4, NaNO3 and so on. Second, salts derived from strong acids and weak bases. For example, NH4Cl, CuSO4, NH4NO3, CuCl2. Third, salts derived from weak acids and strong bases. For example, CH3COONA, KCN and so on. Fourth, salts derived from weak acids and weak bases. For example, CH3, COO, NH4, NH4CN. Now students, these are four types of salts. So how we are going to get the salts, we have studied that. First is from strong acid and strong base, second from strong acid and weak base, and the examples. Now how we get this, we are going to study in detail each of the salt. Before going to study the detail, students, you just have to remember the four types. So how you are going to remember? Just remember the shortcut. That is, the first one is strong acid. So remember S, capital A. This is just a trick to remember, right? So strong acid and strong base. So SASB, first one. Second, SA plus WB. Third, WA plus SB. And fourth, WA plus WB. If you remember this in a shortcut way, this will be easy for you to understand. Now we'll study each of this salt in detail. First, salts of strong acid and strong base. So the salt of SA plus SB, correct. So NaCl is a salt of strong acid, right? Now this, we are studying salts of strong acid, so we have to take strong acid. Strong acid means which dissociates completely. So NaCl is a salt of strong acid. HCl. HCl dissociates completely. We get H plus ions and Cl minus ion. And a strong base, NaOH. So NaOH gives you Na plus OH minus ions. When it is dissolved in water, it dissociates completely into its ions. So how it dissociates? Let us see. So when you take NaCl, NaCl gives you Na plus ions plus Cl minus ions. So the ions Na plus and Cl minus ions have no tendency to react with water. So in this equation you can see only forward arrow. This is because the possible products NaOH and HCl of such reactions are strong electrolytes and dissociate completely in aqueous solutions. In other words, as you can see in the reaction, Na plus ions plus Cl minus ions plus water, it gives you HCl plus NaOH. HCl is a strong acid, NaOH is a strong base. So these are the possible products, right? So HCl aqueous plus NaOH aqueous plus water gives you H3O plus Cl minus ions plus Na plus ions plus OH minus ions. The reactants and the products are the same. This implies that neither the cation nor the anion of the salts react with water, or there is no hydrolysis. So here H3O plus is equal to OH minus ions produced by ionization of water is just disturbed, and the solution is neutral. It may be concluded that the salts of strong acid and strong base does not undergo hydrolysis. Second, the salts of strong acids and weak bases. So salt of Sa plus Wb. CuSO4 is a salt of strong acid H2SO4 and weak base CuOH twice. Now we'll study this. When CuSO4 is dissolved in water, it dissociates completely. As you can see in the reaction, CuSO4 gives you Cu plus 2 ions plus SO4 2 minus ions. SO4 2 minus ions of salt have no tendency to react with water because the possible product H2SO4 is strong electrolyte. The reaction of Cu plus 2 ions with OH minus ions form unionized CuOH twice. The hydraulic equilibrium for CuSO4 is then written as Cu plus 2 ions plus 4 times H2O gives you CuOH twice plus twice H3O plus ions. Due to presence of excess of H3O plus ions, the resulting solution of CuSO4 becomes acidic and turns blue litmus to red. Formation of sparingly soluble CuOH twice by the hydrolysis makes the aqueous solution of CuSO4 turbid. If H2SO4, that is H3O plus ions, are added, the hydrolytic equilibrium shifts to the left. So, the turbidity of CuOH twice dissolves to give a clear solution. To get a clear solution of CuSO4, the addition of H2SO4 would be required. Third, salts of Wa and Sb. So salts of weak acids and strong bases. CH3COONA is a salt of weak acid, acetic acid, CH3COOH, and strong base sodium hydroxide. When dissolved in water, it dissociates completely. As you can see in the reaction, CH3COONA, right? This is a salt. So that gives you CH3COO minus ion plus Na plus ions. Water dissociates slightly as H2O liquid plus H2O, which gives you H3O plus OH minus ion. Now the solution of CH3COONA contains Na plus ion, H3O plus ions, CH3COO minus ion, OH minus ions. So Na plus ions of salt have no tendency to react with OH minus ions of water, since the possible product of the reaction is NaOH, a strong electrolyte. On the other hand, the reaction of CH3COO minus ions of salts with the H3O plus ions from water produces unionized CH3COOH. CH3COO minus ion plus water gives you acetic acid plus OH minus ions. So the hydrolytic equilibrium for CH3COONA is CH3, you can see in the reaction students, CH3COONA plus H2O gives you CH3COOH plus Na plus OH minus ions. As a result of excess OH minus ions produced in the solution, it becomes basic. The solution of CH3COONA is therefore basic. Fourth, salts of weak acids and weak bases. So the salt of Wa and Wb. Now when salt Ba of weak acid Ha, here the weak acid is Ha and the weak base is BOH, and you get a salt Ba. So when a salt Ba from weak acid Ha and weak base BOH is dissolved in water, it dissociates as you can see in the reaction students. Ba gives you B plus ions plus A minus ions. So the hydrolysis reaction involves the interaction of both the ions of salt with water. You can see in the reaction, so Ba plus ions plus A minus ions in water gives you BOH, that is weak base, plus Ha, that is weak acid. The solution may turn out acidic, basic or neutral depending on the relative strength of weak base, weak acid formed in the hydrolysis, as we have already studied students in the 4 types of salts, how we are getting that 4 types of salts. So depending on that, the solution may turn out acidic, basic or neutral, right, on relative strength. It depends on relative strength. So if Ka is greater than Kb, right, so A is for acid and B is a small a and B you can see, so small a is for acid and small b is for base. Suppose if Ka is greater than Kb, the solution will be acidic. If Kb is greater than Ka, the solution will be basic, and if Ka is equal to Kb, the solution will be neutral.